Feel decent about trig? This is not bad. It's a pretty good spread. I like this. I'm confident. You're liking this throwback unit?
Yeah.
Yeah? Yeah? Okay, excellent. So, let's talk about lighthouses. You remember lighthouses.
I love lighthouses.
So, point A, point B. Gives you a bunch of information, right? Right angles. Tells you it's 12 degrees. It tells you it's 30 degrees. And it tells you the distance from A to B. And we'll call this S right here. Tells you the distance from A to B is what?
2 miles.
2. So what information could we fill in immediately right now?
Angle A.
Yeah. Yeah, so angle ABS and SAB. So what do you get here? 60 degrees? And what's 78? And then, to answer the first question, how far is this ship from Lighthouse A? How could we do that directly? What law? So sine of
42.
42. Okay, sure. Sine of 4. Sure, okay. Sure, yep. Over is equal to? Over what? AS, yeah, X, right? And does anybody have AS to 3 decimal places like you're supposed to have it to? 3 decimal places? Pang.
2.588.
How many people got that? Yeah, we agree. We got some popularity there. Good job. Then it asks you for the distance from S to B. Can someone just give me the distance from S to B? It's going to be a very similar method. 3 decimal places. Someone different. 3 decimal places. Yeah.
2.9.
How many people got that? Excellent. So now it asks you to find the distance from, we'll call this S to P. Can someone tell me what they set up to find S to P? Yeah, Claire. Oh, you did the special right triangle? Sure. You know that you have a 30, 60, 90 triangle here. So PS is going to be what? No, could you just tell me what you did? You were about to say it.
So I just divided 2.9.
So you divided SB by what? Yep. And what's that equal? Anybody have an actual answer? 2.531. How many people agree with that? Yeah. Is this the proper use of the special right triangle? What do we think? On a 30, 60, 90 triangle, if the hypotenuse is 1, what are all the other sides? What?
2.
2? Another side is 2? Which one's root 3? Yep, and what's the other one?
Yeah.
Root 3 over what? So another way to say that is 2, root 3, and 1. That's absolutely correct. So on this one, what did we... we had the hypotenuse, correct? We have the hypotenuse of it, and what are we trying to find? The longer side. We have the side, and we want to find the longer side. How do you go from the hypotenuse to the longer side? What do you do? You multiply by root 3 over 2. So it should be SB times root 3 over 2. Does that make sense, everybody? Could you also have used the law of sines or cosines? Sorry, could you use the law of sines to do this? To find that distance? Yeah, sine of 60 over PS. You can use a lot of different things, but sine of 60 over PS, what's that going to equal? How about sine of 90 over 2.924? There's a lot of different ones. You can use the law of sines if you want to on this. You can. Are we okay with this question? Decent. Not bad. Let's move on to your favorite things. Using fists to fives here. 5 being you totally love them and can dominate them. 0 being you hate them and you're terrible at them. What do we think here? 5, 0, what do we think here? 4s, 5s, 0s. People are like, -3. No. So we have a whole range here. It's usually how it is. It's usually how it is. I need to check one thing before we go on. Square what? We're not touching the right side. We're only touching the left side. What? Remove the fractions? Yeah, how are we going to do that? What are we going to do to this? Yeah, do this. 1 plus sine theta? You sure?
One minus.
I kind of want to do 1 minus. I'll show you why. I kind of want to do this because what happens to the denominator? This becomes 1 minus sine theta squared. We can talk about later, but what does the bottom become? 1 minus sine theta plus sine theta minus... What happens to those two signs in the middle? Whoop, they're gone. And this turns into 1 minus sine theta squared all over what? 1 minus sine squared theta. But what is 1 minus sine squared? Cosine what? So we have now 1 minus sine theta squared all over what? Now this is not exactly what we want, but it is. Do we have some squares in there now? Yeah, we actually have some squares in there at this point, which is kind of nice. What do you want to do next? Yeah, distribute it, multiply out the top. So what do we end up with? 1 minus sine theta plus kids, 1 minus sine theta times 1 minus sine theta. So you have 1 minus sine theta minus what? Minus sine theta plus sine theta squared all over. So what do we have here? 1 minus 2 sine theta plus all over cosine squared theta. Yeah. Huh. We're trying to turn this into, we're going to flatten this out, right? Secant and tangent squared, right? If we're stuck, here's one thing you can do. You can take a look at the right-hand side and play around with it to see if you can give yourself some hints. What could you do to the right-hand side to help you maybe figure out what to do next? Yeah, write it in terms of sine and cosine. Minus, what is it? Squared, right? And then what should we do? After we've opened it up like that, what could we do? It's squared, so what could we do? Distribute it out, exactly. If we distribute it out, you end up with 1 over cosine squared theta. Yep. Oh, I did cotangent, thank you. Yeah, absolutely. So what should it... No, but it's cotangent. Oh, it's tangent. So it's going to be sine theta over... So let's multiply it out and see if that helps us. So what's it going to become? 1 over what? Squared theta, right? Minus sine squared. No, it says sine theta over cosine squared theta, right? Is that correct? Ooh, kids, I need your confidence on this. This is 1 minus cosine theta minus sine theta over cosine theta times 1 over cosine theta times minus sine theta over cosine theta. So, what's it going to be? Let's do the first one. It's going to be 1 over theta, right? Minus sine theta over squared theta, right? Correct? It's all cosine squared, right? Plus what? And look what happens. They all have the same denominator, right? So what do you end up with? 1 minus 2 sine theta sine squared theta all over. Look what we have. Is it the same exact thing? So what steps would you take? If you wanted to turn the left side into the right side, you do this, and then you would turn it into that, and then you turn it into that, and then you turn it into that. But if you can make them meet, we worked on one side, we worked on the other side, and we made them look, we turned them into the exact same thing. Are we done? Yes, we're done. Work on one side at a time, and all of your steps will be reversible. All of your steps will be reversible. This, looking at the green right here, going down, looking at the green going down, that's pretty logical. Would you ever really think to do that in reverse? That's a pretty hard thing to see, right? So do it separately on each side, and if you turn them into the same thing, you're done. That's great. Does that make sense, everybody? And then if you really wanted to write it as one direction, you could just take all of this green, reverse the order, and put it right here. Okay, another one that you worked on that you got stumped on. Another one. Hands here. I know you guys worked on a bunch of them because I saw your scribbles. Yes, Alan. Sean, I'm sorry. Can you pick, you want to do this one? Okay. 1 plus sine theta over 1 minus sine theta equals cosecant theta plus 1 over cosecant theta minus 1. Yep. So let's work on that left side. What do you want to multiply by? So we have 1 plus sine theta over 1 minus sine theta. What do you want to multiply by? 1 plus sine theta? Seems like a good thing to do. Maybe that's a good thing to do. Well, what does the top become? 1 plus sine theta all over what? We can skip a few steps. What's the bottom become? Well, it's 1 minus sine squared theta. So that turns into 1 plus sine theta squared all over what? Cosine squared theta. Okay. Fun stuff. What's our real only option at this point? What do we have to do? Let's distribute. 1 plus 2 sine theta plus all over. So that's the right side. And at this point, does it look like there's much we can do? Not really. So what do you want to do now? Let's work on the right side and see what happens. What should I do to the right-hand side? Turn it into sine and cosine, so that's 1 over what? Plus all over 1 over sine. What do you guys? You guys are just letting me do bad things, huh? Sine theta over 1 over sine theta what? What should I multiply this by to clean it up? Over. So what's that become? If I multiply this out, everybody, I need your algebra skills here. You got to tell me. 1 plus sine theta all over what? Oh, wait a minute. What is that? Bingo! Woo! Did we just go back to the beginning by simplifying it once? Yeah, here's the thing. Would you ever think to, yeah, so start on the right-hand side sometimes, and it gives you right back to the left. So you get to here, and maybe you're a little frowny face, because you don't see in identities. Do you see 1 minus sine squared? No, it's 1 plus sine squared. Look on the right. Oh, look! It led us right back to the... Here's the left side. And guess what? We are done. We are totally, totally done. Good. Let's pick another one that looks a little different. You guys are doing real well on these.
22.
22? Sure. Yeah, absolutely. 22. This is a little tricky, but you can definitely do it. How many people tried 22? We're trying to prove that that's equal to 5 plus what?
4 squared theta.
Okay, what's a great thing we should do first? We're working on the left side here. What should we do first? Turn it into sine and cosine. So that's going to be 9 times 1 over cosine squared theta minus 5 times sine squared theta over. There's a lot of different directions you can go in. I want you guys to propose ideas, and I'm going to tell you if it's the best thing to do or not. There's a lot of different ways to make this very long at this point, but there's a great thing you can do first. Take a look over here. What is secant? Cosine. So maybe, are there any other trig functions in this other than cosine? No. We see a lot of cosines, but what do you have left? Sine squared. So, hint, what do you want to do? Yeah, what does sine squared equal? Yes. Please do that at this point. 9 times 1 over cosine squared theta minus 5 times 1 minus cosine squared theta all over cosine squared theta. Now, does this clean up real nice? What do you think? Yeah? You think it does? I don't know. What should I do?
You distribute the 9 and 5 into the...
Add them. We have the same denominator, right? So 9 minus 5 plus 5 cosine squared theta all over what? Is that correct? So what's 9 take away 5? 4 plus 5 cosine squared theta all over what? Yeah. So what's that equal? 4 over cosine squared theta plus what? 5. What is 4 over cosine squared theta? 4 secant squared theta plus? Is that exactly what we need? Is it exactly the same? Yay! What was the magical step there, everybody? This. It gets real nasty real quick if you combine everything. It's something you may need to do on other questions, but it gets real nasty, and then you can go off on these big tangents and eventually get to the answer. This is about as clean as it gets. This is about as clean as it gets. So what tactics did we use? What I mean by a tactic is one thing we did is write everything in terms of sine and cosine. What else are things we did? What other tactics? What? Work, yeah, on both sides independently, right? When necessary, yes. Was it really awesome with one of these? Yeah, one of them it was like, boom, done. What else did we do? Claire? Yeah?
So, like, last year,
Yeah.
we, like, considered it, like, proving it if you got it down to one of the, like, Trig identities, like,
Don't touch both sides at the same time. Don't do that. No. 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 Most of the time, Claire, that will be fine. But not all the time. It is really easy to make a really simple mistake when you're working on both sides at once. So just for the sake of purity of logic, work on one side or the other or both, okay? But yes, that is a valid method in Trig. In Precalculus, I want you one side or the other. Yes? What? That's close enough. Go to lunch. Oh, that's a good question. How about you pick one more? One more. Someone pick one more. A different one. Someone new. Someone new. Take a look at the ones you worked on and actually pick one. Pick something interesting that'll keep us entertained. We'll do a little song and dance. And I might pick another good song. Let's go. Come on. This is how I motivate you. No more Rick Ashley. Please. 59? 59. Nope. Nope. Might give you that for homework. I don't want to work on that one right now. Sorry. What number? Pick another one. 62? Okay. Sine theta plus cosine theta all over sine theta minus cosine theta minus sine theta all over cosine theta is equal to secant theta cosecant theta. First of all, did I copy that down right? That is the most tragic way to cause yourself pain, is to copy it down wrong and then sit there spinning your wheels, like doing lots of proper manipulations. Was it this class that I came up with the great way to, the test I'm going to give you? I'm going to give you like 3 trig identities, and I'm going to ask you which one is not true. Isn't that the best idea ever? Isn't that amazing? I thought that was like, it'd be fantastic. It'd be like a 3-question test. Which 2 are correct? Which one isn't? It's the best idea I've had. So, how are we going to attack this? How are we going to attack this? Do you want to go from left? Let's go from, is it generally easier to condense or to expand? In this, look at this. So, I'm going to ask you the question. Does it look like it's going to be easier to go from the left to the right or the right to the left? Really?
Yeah.
Breaking apart and creating fractions? What do you generally do more often? Do you put fractions together or take... Yeah, but then you have to break it apart. Breaking apart is hard. Basically, it's the same as, it's easier, multiplying or factoring? Multiplying, right? Is it easier to bring stuff together or pull it apart? Generally, it's much easier to pull stuff together. So in this case, if we want to move forward on this, we have to be really careful. How many fractions do we see here? None. How many do we see right here? 2. So let's put it together and then simplify. If we want to put these together, what do we need to have? So that would be the first thing I would try. You want to do this with a little trepidation because you're going to create a common denominator that's going to be kind of not cool, but it might work out. So what do we multiply this one by right here? Cosine theta over, and then we take this one right here, and multiply it by what? Theta over. And what does it turn into? Sine theta cosine theta plus cosine squared theta minus, I'm going to do this in parentheses, cosine theta sine theta minus sine squared theta, right? All over what? Please avoid tragic mistakes. It makes you so sad. So what do you end up with? Sine theta cosine theta plus cosine squared theta plus, sine theta cosine theta plus cosine squared theta minus sine theta cosine theta plus what? Sine squared theta all over. Is this nice? Why is that nice? What cancels? It's not squared. Sorry. What cancels? And what is cosine squared plus sine squared? So what do you end up with? 1 over, which is 1 over sine theta times, which is equal to cosecant theta. And is that exactly what we want? Yes. It's exactly what we want. So what did we do there? What was our key technique here? Add fractions. We added fractions right here, and then what was the step that was really nice here? Common trig identity. How do you prove that sine squared plus cosine squared is equal to 1? What theorem do you need to use? It's a result of what theorem? Yeah. It's a result of the Pythagorean theorem. Because if you know this is a right triangle, if you know that a squared plus b squared is equal to c squared, that's what the Pythagorean theorem tells us, right? If this is theta right here, what's sine of theta? What's cosine of theta? A over c. Let's square them and add them. So sine squared theta plus cosine squared theta is equal to b squared over c squared plus over c squared, right? Is that correct? What does a squared over c squared plus b squared over c squared equal? What? C squared over? Okay, kids. This right here, we know that. We're trying to figure out what that equals, right? We know that a squared plus b squared is equal to, divide everything by c squared. What do you get? So that's equal to c squared over c squared, which is equal to 1. So therefore you know that sine squared theta plus cosine squared theta is equal to 1. And then how do you get the other triples? Divide everything by sine squared. So this is the first one, right? Divide everything by sine squared and you get 1 plus cosine over sine is cotangent squared theta equals what's 1 over sine? What's 1 over sine squared, everybody? Cosecant squared theta. There's some confidence. And then if you go to this one, you divide by sine squared. Sorry, if you divide by cosine squared instead, what do you get? Well, what's sine over cosine? Tangent squared theta plus what? 1 is equal to 1 over cosine is? These are the 3, right? But they're all a result of this. Those are the Pythagorean trig identities. Good? So you feeling okay about these trig identities? Ish? Ish, ish, ish?